Good afternoon, Dr. Fauzi. My name is Henry, the leader for Group 1. Today, we will be discussing about the importance of quality control and the 7 QC tools and their application in the real-world case involving Plexus Corporation. Quality in the realm of quality control is about meeting customer needs and expectations. It encompasses attributes like functionality, reliability, durability, serviceability, and aesthetics. It's not just about the end product, but extends throughout the production process. QC tools are essential in modern business operations, particularly in precision-driven sectors like manufacturing and services. Traditional and advanced quality control tools help identify and resolve quality issues. In our project, we offer advanced methods for problem-solving and decision-making. These include affinity diagrams, interrelationship diagrams, tree diagrams, matrix diagrams, Pareto diagrams, Ishikawa diagrams, and flowcharts. Our case study focuses on Plexus Corporation, a global leader in product design and electronics manufacturing. We'll explore how the QC tools can help them improve their operations and maintain a competitive edge. And our objectives are to identify the main problems at Plexus. And secondly, to determine the root causes of the problems. Thirdly, to propose recommended solutions aligned with Plexus goals. And lastly, to evaluate the priority of these solutions. Next, moving on to the background of the study, Plexus Corporation, a global leader in the product design, electronics manufacturing, and engineering services, has experienced significant growth in the electronic circuit board production since the 1990s, with 25,000 employees and 28 manufacturing facilities. They provide top-tier contract engineering, manufacturing, and design services to around 140 enterprises customers globally. And our industry visit was to Plexus Riverside Facility branch, which is located in Pulau Pinang, Malaysia. As for the methodology used, the research utilized a mixed method approach, primarily qualitative, to identify major problems and propose solutions using the 7 QC tools. Data collection included factory visits, interviews, surveys, and document analysis. The study also included a literature review and peer review to ensure reliability and validity. The research aimed to understand the effectiveness of Plexus's quality control strategies and identify areas for improvement. The findings were analyzed using various tools, including Pareto, Ishikawa, affinity, relationship, tree, and matrix diagrams.
My name is Cecilia Tanwenli, and my matrix number is AP220162. Moving on, I'll be talking about the use of flowcharts to help understand the manufacturing process of Plexus Corporation. The process flow for product development and manufacturing involves a comprehensive approach that includes client requirements analysis, design and engineering, supply chain coordination, prototype development, testing and validation, manufacturing setup, quality assurance, assembly, packaging. The process begins with client requirement analysis, evaluating the client's needs, and then processes to the design and engineering phases. If feasible, the product is sent back to the drawing board for the redesign. If materials are available, the process moves to prototype development. If necessary, alternative sources are sought. The prototype is tested and validated. And if successful, the manufacturing setup is establishable. Quality assurance involves inspection through optical inspections (AOI) and X-ray inspection. If the assembly process is efficient, the process moves to the packaging stage. If efficient concern arise, the assembly line is optimized.
My name is Daniel. My matrix number is AP220245. Now I will explain about the main problem that faces by Plexus company. The main problem of Plexus company is the problem in manufacturing line. There are some causes that affect the manufacturing line, and the most serious cause is equipment malfunction. With the feedback from 15 people of their employee, equipment malfunction accounted for 35% of the causes. This category includes situation of mechanical failure and maintenance problem that describe the manufacturing process, followed by the problem of supply chain delay, which comprise for 25% of the issues. Supply chain delay issues include delays due to supplier issues, logistic challenges, or material shortage, which will impact the seamless flow of components needed for manufacturing, causing production schedules to be slowed down. The third causes of problem in the manufacturing line is quality change, which support by 9 employees. This problem often arises during the manufacturing process, resulting in the need for rework due to quality-related issues. Next, staff shortages have also been a cause in the manufacturing line problem, with a total of 10%. Absent or lack of properly trained affect the smooth operation of the production line, possibly resulting in slowdown or inefficiency in manufacturing line. Technical glitches accounted for 8% of the problems, representing challenges that disrupt the manufacturing process. These technical glitches prevent the seamless operation of machinery or technology in the production process, causing disruption, delays, or reduced quality. Other than that, inadequate training support by 3 employees, highlighting the profound impact the lack of proper training within Plexus. This deficiency affects the entire organization to perform tasks effectively or poor quality in work. Lastly, communication barrier becomes the smallest cause in the manufacturing line, with a total of 2%. This problem can lead to misunderstanding or inefficiency in operation, affecting overall productivity and coordination.
So, the next step is to identify the causes of the problem in Plexus Corporation. Using the Ishikawa diagram, also known as the fishbone diagram, we discovered that there are 6 primary causes of the problem, which are machine, method, materials, man, measurement, and the environment. In the machine category, electrical issues like short circuit or power fluctuation are major contributors, potentially harming critical components. Faulty components from manufacturing floors or wear and tear leads to failure. Overloading generates stress, causing overheating and faster wear. In the method category, hardware and software driver issues disrupt plant activities. Physical damage or failure in hardware components disrupt operations. Software faults or updated drivers causes mistakes. Firmware errors add complexity to the challenges. Into the material category, substandard material damage equipment longevity, improper handling during shipment, installation, or operation causes physical damage. Contamination with pollutants affect equipment accuracy and longevity. In the man category, poor communication leads to misunderstanding, inadequate skill personnel result in incorrect usage and troubleshooting. Lack of oversight can contribute to neglect of routine maintenance, failure to address emerging issue promptly, and increased chances of human error in equipment operation. Into the measurement category, incorrect measurement leads to incorrect data analysis, calibration issue cause measurement mistake, sensor malfunction impact equipment control. Lastly, the environment category. Temperature fluctuation, auto mechanical and electrical tolerance, network issue disrupt information flow, high humidity and excessive vibration affected equipment reliability.
My name is Henry Wu Erhan, and my metric number is AP220253. And I will be explaining about the use of affinity diagram in our project. So, we identified 6 categories of cause of equipment malfunction in the Plexus Corporation, consisting machine, materials, method, man, measurements, and environment. Machine issues include outdated machinery, lack of maintenance, inadequate cooling systems, software glitches, and robotic arms. Human factors include fatigue, staffing issues, lack of expertise, insufficient communication, and resistance to new technology. Method issues include inadequate training, insufficient workflow design, suboptimal assembly techniques, and inaccurate testing methods. Measurement issues, next, include inaccurate measuring instruments, calibration equipment, and data recording errors. Material issues involve low-quality components, contaminated soldering materials, insufficient supply of essential raw materials, incompatible materials, and outdated firmware. The environment impacts equipment function through uncontrolled humidity, dust, contaminants, power supply fluctuations, inadequate temperature control, and poorly designed ventilation systems. Overall, these factors contribute to equipment malfunction and hinder the company's ability to operate effectively.
My name is Sanyu Chen, number matric AP22023. Now we'll talk about the interrelationship diagram. The interrelationship diagram shows that there are 29 causes to equipment malfunction that has interrelation to each other. All machinery breakdowns, often intensified by a lack of maintenance, create bottlenecks in our production flow. Inadequate cooling systems and environmental control add to this, leading to overheating and disruptive glitches, affecting the precision of our operations. Furthermore, the smallest discrepancies in machinery calibration or the use of low-quality components can snowball into significant issues such as electrical failures, poor connections, and corrosion, which are all culprits that degrade our product quality and longevity. As for the human factor, from insufficient training to inefficient workflow designs, our workforce encounters hurdles that impact their efficiency, fatigue, inadequate staffing, and resistance to change contribute to the challenges we face. Moreover, measurement discrepancies and the lack of real-time monitoring exacerbate these issues. Misguided decisions based on skewed data and measurement errors can lead us astray. Our production environment, due to uncontrolled humidity, dust, and voltage fluctuations, not only impact our machinery but also affect the integrity of our materials and the well-being of our workforce.
Challenge we encounter is aging machinery. Strategy is throughout inspection to assess the current condition of the equipment. We identify signs of wear, potential failure points, and safety concerns. To enhance proactive maintenance, we propose the installation of condition monitoring system that use sensor and data analytics to track real-time health, enabling swift interventions. Complementing these measures is a robust spare parts management system, creating an inventory for timely replacement and minimizing downtime. So the second challenge is the lack of regular maintenance. Vessels can enhance maintenance practices by providing specific schedules and checklists for each piece of equipment. These schedules detail duties, frequencies, and precise processes, establishing a methodical framework. So substantial training for maintenance workers instills the importance of routine maintenance, develops an understanding of correct processes, and equips personnel with the skill to spot early indicators of wear. Dedicating maintenance personnel to specific equipment promotes accountability and a proactive maintenance culture. So next, the pro-environmental conditions require a combination of preventative and precautionary efforts. Our strategy involves the implementation of real-time environmental monitoring system to track key parameters, the integration of alert mechanisms, facilitates proactive intervention by notifying personnel of conditions that could lead to equipment malfunctions. Simultaneously, we propose selling equipment against to environmental elements and applying insulation measures to shift it from temperature, fluctuations, and corrosions. Regular equipment inspection further ensure the resilience in adverse operating conditions. So to address the equipment malfunction caused by insufficient training and competence, our complete solution involves a multifaceted training approach. Structured training programs cover essential skill and knowledge for both new and existing personnel. So hands-on training section provide practical experience, and mentorship programs foster a supportive learning environment. So through the mentorship, knowledge transfer and skill development are actively encouraged and contributing to a well-rounded and capable workforce.
Now we talk about evolution solution. Based on the matrix diagram, we must select operation scenarios. The scenarios include effectiveness, long cost, and improve employee capability. Prsentation goal to ensure that solution is successful. Since an effective solution, it may impact the overall efficiency of the manufacturing process. Based on the 12 options and 3 scenarios, we utilize 3 integration ranks. The higher mark is training program is 74, and the lower mark is trained maintenance personnel is 38.
Moving next to the final discussion. Our report examines the Plexus Corporation's manufacturing issues using 7 quality control tools. Our group used Pareto analysis, Ishikawa diagram, affinity diagrams, interrelationship diagrams, tree diagrams, and matrix diagrams to identify, analyze, and address productivity challenges. Our project demonstrates the practical application of these tools in real-world manufacturing contexts, demonstrating the value of effective communication, critical thinking, and adherence to academic standards and professionalisms. Finally, in conclusion, our study at Plexus Corporation revealed that equipment failure is the main cause of production line problems, accounting for 30% of all of the difficulties. Solutions include managing old machinery, enhancing employee training programs, addressing environmental issues, and improving routine maintenance procedures. Training programs are most successful in improving staff capacity, efficiency, and cost effectiveness. So, implementing these strategies could significantly improve the production process, productivity, and overall operations. So, funding for employee training activities is crucial for addressing the root causes of equipment failures. With that, I would like to end our presentation. Thank you.